Find the sort of syntax first for the useful tools that you may need. Wear the pendant of performance for efficiency and speed. Caution's crystal clears the sky with triple equals and try catch, avoiding stuff that sucks and parsing better numbers out of stretch. At last the golden shining mail of modularity. When namespace closure imports long defend integrity. For polished skills in JavaScript, the treasure trove this is. Now raise your sword and strike your shield with these best practices.
No best practices course would be complete without a section that warns you of the dangers that lurk within the seemingly harmless aspects of a language. So in this level, we'll first examine how to craft the most careful comparisons between our data values so that we get the results that we expect, as well as how to provide our programs with the most effective response to the errors that can and will rear their ugly heads. Next, we'll look at some badly misused methods within JavaScript, as well as some alternate methods for how to avoid the negative consequences of that misuse. Lastly, we'll turn to numbers, within which JavaScript sometimes has some unexpected results, and we'll outline ways to improve our experience with that numerical data. So if you're ready, it's time to look within the crystal of caution. Hey guys, welcome back to JavaScript Best Practices. This is Level 3, the Crystal of Caution. In this section, we'll be examining how to make careful comparisons. Now you might be aware, but not all equality comparisons are equal. The triple equals comparator in particular is going to compare both type and contents for us. So take a look at these two comparisons. In this first comparison, we've got the string 4 being compared against 4, the number 4, with the double equals. And that returns a true, which is kind of weird. Double equals tries to help us out with some type coercion. It thinks you want to know whether 4 is 4, but that's not always the help we want. Over here on the other comparison, we've got the string 4 being compared with triple equals against 4, and we get false, which is exactly what we wanted if we wanted to know whether we have both similar type as well as contents. Looking at a few more of those, you can see the true and false comparisons with double and triple equals here. And double equals thinks true and false are both 1 and 0, whereas triple equals does not. That's because by historical convention within computer science fields, true and false have traditionally represented 1 and 0 respectively. Triple equals, however, it doesn't care. It first sees a Boolean and then a number and it says, yo, those things ain't the same, sorry. You want to see something really weird about type coercion? Check out this string that only has escaped characters in it. Well, the JavaScript interpreter thinks that you want to know whether that string that has really no contents in it is equal to 0, and so that's going to return a true, which is slightly weird. So the triple equals in that case would help us out and return that those two things are not at all the same. The important thing here is that triple equals seeks a very strict equality. It ensures comparison reliability in all of these environments where the data types that you get back or receive from places may be unknown, right? It's very helpful. Let's say we had a website with some fields in it, and it was a new registration website for knights that are about to become knights but have to complete a certain amount of requirements in order to become a knight. Take a look at this function called countEntries. It's going to take in an array of responses from those fields called knight responses. It's also going to take in a value that we're looking for. We're trying to count with countEntries how many of the responses are the value in question. Inside we establish a count variable, and we also cache the length of our knight responses array, and then we loop over that array to count exactly how many responses are the value that we seek. Finally, we return the count variable. Cool, so our knights need to have all these knightly tasks completed, right, in order to be able to participate in their induction, in order to be inducted as a knight. So I'll fill in my stuff here, and I am Jason Millhouse, and my regiment is 1, and my squad is 12, and I have a squire. My squire has already been signed to me, and I also have a weapon issued. However, I have not completed my captain's interview yet. So as these fields get submitted through the behavior of the website, we're going to get an array compiled that has all of my responses in it. We got Jason Millhouse as the name, 1 as my regiment, 12 as my squad, and true, true, false for the yes, no answers. Now, if I wanted to know how many completed tasks I had actually performed, then I could call count entries on my fields responses and tell the count entries function that I wanted to know how many of my completed tasks were true. Then if I were to log out my num completed tasks, I get 3. Well, that's not right. I've got 2 yeses and 1 no. It shouldn't be 3, so what happened? You probably can tell. Over here in our function, we've got a double equals comparison of a night responses entry with a value, but guess what happens as a result of that? When I get to that number 1 for my regiment value, my count variable is going to be incremented because the double equals type coerces my 1 to be a true value. And when that actually gets compared, it returns true. So let's go ahead and fix that situation. If we throw out the double equals, insert a triple equals, now we get exactly what we're looking for. A 2 comes back from our console log. That's because the string 1 is not in fact the same thing as the Boolean true, and we get a false through that comparison. The moral of this story, my friends, is that you should always be very careful when you are checking in your comparisons, and that very often the triple equals comparator is the best practice in most unknown data type environments, and even in known data type environments. The next comparison we want to check out is what happens when we need to verify an object's class. What if we want to execute operations only if an object has been built by some kind of specific constructor, right? Or whether it has a specific prototype. Let's take a look at that. Let's say we had 2 types of armor here. We got leather armor and we got chainmail, right? Leather armor's got body style, num buckles, num spalders. Chainmail's got what type of metal it is, the link diameter, whether it's got a hood on it, how long the skirt is. Now, where are all of the objects that come from these constructors? Well, they're in a variable called armor list, which is a mixed up list of the kingdom's armory's available armor objects, right? And underneath that, we've got our noobs array, which is a list of knights objects, and these guys ostensibly need some armor in order to be a knight. But, well, knights only get chainmail, right? So how can we find which armor objects actually are chainmail using comparisons? Well, if we just loop over the entire armory's list, passing out armor to knights nilly-willy, some might end up with leather armor, or even worse, what if they ended up with a helmet for their body armor? That would be really challenging and problematic. So enter the instance of operator. It's going to help you precisely identify your objects in all cases. You want to use this operator to ensure that you're examining precisely which object your code should expect. So let's build a function here called assign knights armor, right? And we're going to pass in a list of knights, and we're going to also pass in the list of all the armor that is available. We're going to go ahead and cache our array lengths for efficiency ahead of time. You can see we got X getting knights.length and Y getting armoravail.length. Now we'll loop over every knight that needs some armor. We got a nested loop here, and for each one of those knights, we'll then check through the armor array to find some chainmail. Inside that loop, we're going to check if the armor avail on a bracketed J for whichever loop index we've arrived at is an instance of chainmail, if it's an instance of the chainmail object. Then we will assign a new armor property to whichever knight we're looking at. Notice the ith index there, which signals the outer loop or which knight we're looking at. Then we will splice that armor right out of the armor list, and we will return an object from the array that gets returned from splice, and then we will pass that chainmail object straight into the armor property of whichever knight we're looking at. Notice that the ith index signals which knight we're looking at. Now, since we've taken an object out of our armor array, we need to go ahead and modify our cached length so that every time we get to that innermost nested loop, we don't go out of bounds on our array of armor. And since the current knight has some armor now, we can go ahead and break out of the innermost for loop. Cool, we got a function. Time to give some of these newbies some chainmail, man. So let's fill the list with a little short example, and we'll check out the results of our armor identification process. So let's build a couple sample arrays for our instance of test here. We're going to get our armor list. It's going to have a leather armor, a chainmail, a leather armor, and another chainmail. And then we have a noobs array, which got 2 new knights in it. Cool. Now we will begin our assign knights armor function. We will pass in our noobs array as well as our armor list. So the first thing that happens is for that first knight, we look for the very first armor object, and it is leather armor. So what happens? When we get to if armor avail instance of chainmail, that's going to return a false. And so we will skip that object entirely, and the loop will move to the very next object, which is a chainmail. And that's exactly what we want for our knight, and so that chainmail gets assigned to our very first knight object. You can see now that the chainmail pieces out of that array. So the next thing that happens is we break out of our loop so that we can move towards the next knight because our first knight already has his armor. And then we look again throughout the armor list to find a new chainmail for our new knight. Well, the first thing we get to is a leather armor. That's no good. Then we get to a leather armor again, and that's because the previous chainmail has already been given to the first knight. Finally, we get to chainmail, and that means that our armor avail instance of chainmail will now return true. And so that knight gets a chainmail, and we are good to go. That chainmail gets deleted from the array, and if we were to log out our new armor list, we can see we've only got 2 leather armors in there now, no more chainmail objects. Thank you very much, instance of. Cool other thing, if we were to log out, let's say our first knight, which would be noobs 0, we'd probably see a bunch of other properties inside that object, and also an armor property with a chainmail object. Cool thing about instance of as well is that you can check the entire inheritance chain with it. An object happens to be an instance of all the prototypes from which it inherits properties, which is very useful. If you need to make sure an object actually has access to properties before trying to call those properties, that happens very frequently. So if we built a armor constructor and it had a location and we just gave it a location property, and then we also built an armor prototype that had apparently the put on function so that any armor anywhere could call the put on method. Now we've got a prototype for our armor and a constructor for it. And then we build prototype objects for the leather armor and chainmail constructors, and these new prototypes have as their prototype the armor prototype. We do that using the object.create method, which, as you may know, takes in a prototype upon which to base the newly created object that comes back from the call to object.create. This makes the armor prototype the parent prototype for both leather armor and chainmail, which makes sense, right? And then over here, if we had a kingsmail variable and we assign to it a new chainmail object, and we're going to pass in gold because the kingsmail should of course be gold. He's got a 2-inch link diameter as well as a hood on that chainmail, and his skirt length is 36 inches for full protection. This particular usage of instance of can be very useful if you have to make sure an object actually has access to some properties before you try to call them. Then if we were to log out whether the kingsmail is an instance of armor, we get true, and that's because every chainmail everywhere will always be a child of the armor.prototype. So now that you have a little bit of experience with some comparison best practices, we will send you over to the challenges and see you back real soon.